everywhere. Ladies and gentlemen, I call this hearing of the Emerging Threats and Capabilities Subcommittee of the House Armed Services Committee to order. I am pleased to welcome everyone here today for today's hearing on advancing the science and acceptance of autonomy for future defense systems. The military necessity for autonomous systems is obvious. Many of us recognize that our military is not large enough and is not likely to grow sufficiently over the next few years to handle all the threats we face. On top of this, shrinking budgets will shrink our military, stretch our military men and women and platforms even further to be able to accomplish their ever-changing and challenging missions. The promise of autonomous systems is becoming more evident every day, from self-driving cars to smart buildings to increasing presence of robotics. The full potential of autonomous systems is nearly endless. What is less understood are the technical and policy challenges that must be identified and solved to make those visions a reality. Most of us are more likely to understand what is possible with examples provided from television and movies, so I'm looking forward to having real experts shed light on what the actual state-of-the-art technology is and what the path to acceptance looks like for the military services. And with this backdrop, we look forward to hearing from today's panel of witnesses who will educate members on many of the issues related to autonomy research and the development of increasingly autonomous systems. And we do have a challenge. Votes have just been called, and we'll be introducing everyone, and then we'll recess and then come back. And so our witnesses today, Dr. Greg L. Zacharias, Chief Scientist of the U.S. Air Force, Mr. Frank Kelly, Deputy Assistant Secretary of the Navy for Unmanned Systems, Dr. Jonathan Bornstein, Chief Autonomous System Division, Vehicle Technology Directorate, Army Research Laboratory. And before we recess, I'd like to turn to my friend, the ranking member, James Langevin from Rhode Island, for any comments he'd like to make.
Well, thank you, Mr. Chairman, and I want to thank you for convening this hearing. I want to welcome our witnesses. It's certainly always a pleasure diving into these issues with you, and I appreciate your convening this hearing this morning. So again, thank you to our witnesses for appearing before the subcommittee to provide your insights regarding advancing the science of autonomy as well as the challenges with its acceptance. Increasingly, autonomous systems and capabilities have provided a significant advantage to our warfighters by augmenting their skills while also decreasing the risk to their lives. Some of those systems, such as the human-supervised Aegis combat system, point defense systems such as Phalanx and ISR systems, have been such game changers that they have fundamentally altered our strategies and doctrine. For just one example, as members of the ETC subcommittee, we are extraordinarily familiar with how remotely piloted aircraft and identifying, tracking, and queuing capabilities they carry have not only changed techniques, and procedures, but also shaped our counterterrorism strategy. Although we've begun to realize the potential of unmanned systems for military applications, we've yet to grasp the full potential of autonomous systems. Incorporation of unmanned platforms has been driven by demands in current areas of operations, and those same demands will drive us towards usage of increasingly sophisticated autonomy in all domains: air, ground, sea, space, and cyberspace. Bearing that in mind, it's troubling that the 2012 Defense Science Board report entitled "The Report of Autonomy in DoD Systems" concluded that there are several hurdles precluding broad acceptance of autonomous systems in the department, thereby hindering advances in science and technology. I do recognize that there have been changes and progress on the subject and science of autonomy in the department since the DSB report was issued. In the fall of 2014, Undersecretary Kindle announced the commissioning of a new study focused on the science, engineering, and policy problems that must be solved to permit greater operational use of autonomy across all warfighting domains. Most recently, the Secretary of the Navy established a new Deputy Assistant Secretary of the Navy for Autonomous Systems, and a new office to coordinate all aspects of unmanned systems. And Deputy Secretary work has indicated autonomous systems will play a significant role in the third offset strategy. Today, I hope to have a robust dialogue on how we can advance the science, utility, and acceptance of autonomous systems. I hope that we can discuss the following. First of all, definition. How should we define autonomy? How should we distinguish between the degrees of complexity of autonomous systems, and how should we distinguish future autonomous capabilities? Next, command and control. Who is ultimately responsible in the chain of command as systems become more independent from operators? Should certain lethal capabilities remain with a human in the loop or become autonomous, akin to point defense systems? When and how should we revisit these determinations? Next, integration. How will we integrate autonomous systems and capabilities with manned and other unmanned systems across all domains? Next, science and technology. How do we better transition advancements and capabilities? How will the Department create a cohesive testing and training strategy that provides confidence at the strategic, tactical, and operational levels for maximum employment of the capability? And what hurdles must be overcome to formulate those strategies? Given that such autonomy research is being undertaken in the private sector and in our labs and academic institutions, how and to what degree do we leverage that work? And finally, security and risk. How do we ensure software and hardware systems are secure and verified? How will we understand and measure the risk associated with employment of autonomous systems? So with that, Mr. Chairman, I look forward to our conversation and our witnesses' testimony, and with that, I yield back.
Thank you very much, Mr. Langevin. And as indicated, we are having votes on the floor at this time. There are 4 votes. There will be, sadly, a significant delay, but we are recessed. Armed Services Committee. We have recessed for votes, and the votes are concluded, and we can proceed. And I'd like to remind every one of our witnesses that your written statements will be submitted for the record, so that we ask that you summarize your comments in 5 minutes or less. Thank you for being here today. We begin with Dr. Zacharias.
Chairman Wilson, Ranking Member Langevin, members of the subcommittee, thank you for the opportunity to provide testimony on how the Air Force is advancing science in autonomy and the acceptance of the autonomy for future defense systems. I deeply appreciate your devoting time to this topic. Just as a little addition to my background, I've been working in the man-machine area for over 40 years, first helping to design the Space Shuttle autopilot, later working with flight simulation, and most recently with systems providing computational intelligence to help humans make better decisions. The current focus on autonomous systems calls on many of these technology areas, and I'm delighted to be in the middle of it right now. My current role is chief scientist. I hope I can help explain today some of the issues involved in the development of these systems. In the Air Force's vision for autonomy in future systems, we seek the right balance of human and machine teaming to meet future operational challenges by combining increasingly capable hardware and software systems with unique human abilities in perception, judgment, and innovation. The goal is to have human autonomy teams operate effectively in high-tempo, uncertain, and complex decision environments where humans and machines can work together effectively, efficiently, predictably, and robustly. Boiled down to its essentials, the Air Force's autonomy science and technology vision is intelligent machines seamlessly integrated with humans, maximizing mission performance in complex and contested environments. So as machine capabilities advance, the Air Force's technology development approach is to keep the airmen at the center of the system design. Likewise, the Air Force's operational vision is to keep the airmen at the center of the critical decisions that occur throughout a mission and engagement. The ultimate goal is to ensure effective teaming of the airmen with the autonomous system for better agility, effectiveness, and mission success. Embedded in this vision are three strategic objectives, if you will. First, the development of sensors and data gathering technology that can provide the needed information for a system to better understand its operating environment and mission goals, basically the context. Second, the development of reasoning systems and software environments to assess situations to make recommendations or decisions. It's the computational intelligence part of it, if you will. And then finally, the refinement of different ways for carrying out those recommendations and decisions, whether through direct actions such as guiding an unmanned platform or through recommendations to another human or machine teammate. The overall goal here is to enable systems to react appropriately to their environment and perform situationally appropriate tasks, synchronized and integrated with other autonomous human or machine systems. The payoffs include a greater ability to prevail in increasingly tested environments over greater ranges and time spans, protection of airmen from dangerous and harsh environments while increasing their mission effectiveness, reducing the time to conduct time-critical operations, such as in defending our airspace and cyberspace assets against high-tempo threats, providing increased levels of reliability, persistence, and resilience, and then finally reducing manning costs, as was mentioned earlier. In your invitation to me to testify, you asked me to comment on how the Air Force has implemented the recommendations of the 2012 Defense Science Board Autonomy Report, and I hope that between my written statement provided earlier and my comments here today, I'll have demonstrated that the Air Force has been very responsive to the DSB recommendations and is leading the way in terms of autonomy research and use of autonomous systems. Thanks for letting me speak on this exciting topic and for your interest in this game-changing technology. I look forward to answering any questions you may have.
Thank you very much, Dr. Zacharias, and indeed it is game-changing, and I appreciate your enthusiasm and recognition of how important what you're doing. Thank you very much.
Thank you.
Mr. Kelly.
Chairman Wilson, Ranking Member Langevin, and distinguished members of the subcommittee, thank you for the opportunity to speak with you today. It's my pleasure to testify this morning beside my Army and Air Force counterparts as the Navy's first Deputy Assistant Secretary of the Navy for Unmanned Systems. I'd also like to thank Mr. Gates for coming down and seeing us at the Pentagon. Really appreciate that. And it's not lost on me, gentlemen, that in my past life I would find comfort being flanked by two PhDs and have grown accustomed to the safety of such intellectual supervision. So thank you, gentlemen, for doing that for me. So, unmanned and autonomous systems are going to transform the future of how we operate as a Navy and as a military. However, unmanned technology will not diminish the importance of our most fundamental asset, our people. Instead, unmanned and autonomous systems, which allow us to exceed human limitations, will be used as powerful force multipliers across our fleet. Using autonomous systems in roles for which machines are best suited allows us to strategically employ sailors and Marines for roles in which people are best suited. The research and development work the Navy and Marine Corps is conducting to improve our autonomous capabilities for future military systems is impressive, from the early research and cooperative behavior to autonomous takeoff and landings of our unmanned aircraft. These innovations in autonomy, however, need to be nurtured and introduced in a manner which will gain the trust of our sailors and Marines and the public we are here to protect. I hope the committee will come to appreciate the deliberate and disciplined nature in which the Navy and Marine Corps are investing time and resources in the development and experimentation with this technology. It is also important to understand that realizing the vision of a fully integrated unmanned and manned naval force will depend as much on significant military cultural evolution as on the technology innovation. We have to change the way we think to evolve the way we fight. The strong leadership within the Navy today is laying down the foundation that will allow us to realize the vision of a fully integrated future force. This past April, the Secretary of the Navy announced that he was creating a new organization to focus and guide the Navy's efforts on unmanned systems. Under the strong leadership of the Assistant Secretary of the Navy for Research, Development, and Acquisition, in order to create the Office of the Deputy Assistant Secretary of the Navy for Unmanned Systems, and to bring together all the many stakeholders and operators who are currently working on this technology in order to streamline their efforts. Additionally, a new resource sponsor was established under the Chief of Naval Operations. OPNAV N99, or Unmanned Warfare Systems, was created so that all aspects of unmanned in all domains will be coordinated and championed. As of the 2nd of November, both organizations have been officially stood up and populated with highly qualified individuals from across our Navy and Marine Corps. Prior to our official establishment, the groundwork commenced over the summer, and the two organizations have collaborated with the DASN for research, development, test, and evaluation to develop a cross-department prototyping and experimentation approach that embraces innovation. To work rapidly to harness the potential of unmanned technology into deployable systems is built upon the incredible foundation laid by our Office of Naval Research and the Naval Research Laboratory. These two organizations have a rich history of basic and fundamental research in autonomous and unmanned systems conducted by world-class personnel and world-class facilities. However, despite the ample research that has been done, and despite the claims of some, autonomy is not a solved problem. There is much work to be done before we can realize our vision of a fully integrated manned and unmanned force. Autonomy still provides a host of unique challenges. Furthermore, autonomy alone will not ensure a secure America. We must understand the limits of autonomy, and in so doing, come to more fully appreciate the advantages of being a human. In this way, we will be able to build an effective teaming relationship between people and autonomous systems. The development of trust within this team will be critical to the success of all of our missions. We have a moral imperative to equip our sailors and Marines with the best capabilities to do their missions. However, we also have a moral imperative to ensure that in addition to the technology innovation, we develop an ethical, legal, and policy framework for how we will employ unmanned and autonomous systems. Even as we carefully and deliberately build this framework, we also recognize that we have to be able to robustly defend against adversaries who do not play by our rules. Unmanned and autonomous technology will transform the way we operate. Your Navy and Marine Corps are committed to understanding and forging an effective relationship between man and machine that will unlock our full potential of both. Chairman Wilson, Ranking Member Langevin, and distinguished members of the subcommittee, thank you again for the opportunity to speak with you today, and I look forward to answering your questions.
Thank you, Mr. Kelly, and we appreciate your prior Marine service, too. We now proceed to Dr. Bornstein.
Chairman Wilson, Ranking Member Langevin, and other distinguished members of the subcommittee, thank you for the opportunity to speak with you about the research and development work currently being pursued by the Army to improve autonomy capabilities for future military systems. The recently published Army Operating Concept notes that the application of emerging autonomy technology creates the potential for affordable, interoperable systems that improve the effectiveness of soldiers and units. That document provides the vision that, quote, autonomous and semi-autonomous operational capabilities may increase lethality, improve protection, and extend soldiers' and units' reach, unquote. The Army Training and Doctrine Command, together with the Army's Science and Technology, Acquisition, and Test and Evaluation communities, is developing the Robotics and Autonomous Systems Strategy to implement this vision, creating a roadmap for autonomy technology development, material acquisition, and training for the next 30 years. In his recent presentation at the Reagan Presidential Library, the Deputy Secretary of Defense noted that autonomy technology has reached an inflection point. The technology is now being pursued widely. It is being pursued globally and by the commercial sector. There are differences, however, between the commercial and military application of this technology. Commercial usage generally focuses on benign, permissive, and structured environments. The military must design for adversarial, highly dynamic, and structured environments. In the near term, the Army community has undertaken efforts to gain experience with these complex software systems. TRADEX Centers of Excellence have utilized the ongoing network integration evaluation and beginning this fiscal year, the Robotics Enhancement Program, to place surrogate experimental autonomous systems in the hands of soldiers. Such experimentation will inform and aid development of future requirements, doctrine, tactics, techniques, and procedures required to effectively employ this new capability. For the mid and far term, the science and technology enterprise's efforts are focused on 7 main thrusts. It is focused on the maturation and demonstration of advanced manned-unmanned teaming for both air vehicles and ground vehicles to permit unmanned assets to serve as wingmen to manned elements of the force. It is exploring the effective teaming of unmanned air and ground vehicles. It is developing robotic technologies and capabilities that will enable unit resupply and sustainment operation using optionally manned and unmanned vehicles. And it is developing the cognitive decision tools for effectively commanding teams of advanced unmanned systems. In addition, it is conducting research focused on creating the technology to seamlessly integrate unmanned elements, both air and ground, into small unit teams, and research to enable the development of swarms of unmanned systems capable of effectively conducting military missions at range. Taken as a whole, these efforts will provide the underpinnings for autonomous systems that can operate side by side with our soldiers on the battlefield in applications ranging from resupply to reconnaissance. Although the autonomy technologies available today work well for the sets of conditions for which they were designed and tested, they lack the flexibility and adaptability that would enable them to work well for other situations. Systems using today's technologies must be teamed with humans to supply the cognitive capability required for complex missions, while the unmanned component of the force performs repetitive or persistent tasks. Significantly advancing autonomy technology, taking machines from tool to teammate, will require technology advancement beyond what is available today. In conclusion, once again, I'd like to thank Chairman Wilson, Ranking Member Langevin, and the other distinguished members of the committee for the opportunity to discuss the Army's role in pursuing autonomous capabilities for future military systems. The Army is committed to developing autonomous systems that can, one day, work side by side with our soldiers. I look forward to your questions.
Thank you, Mr. Bornstein. And with 3 sons serving in the Army, I want you to be very successful. And we now will proceed to 5 minutes of questioning by each member of the panel. Fortunately, we have Kevin Gates as our staff person who is very strict on maintaining the 5-minute rule, beginning with me. And so we'll begin with Dr. Zacharias. You mentioned in your testimony the concept of autonomy at rest. Could you explain that in more detail for the members so we can better understand what is important?
Yes, sir. Yes, sir. And I should give credit to Dr. Craig Fields, the past director of DARPA, for that's where I heard the phrases originally. But the notion is that we tend to think of autonomy in motion because of the RPAs and the UAVs that were recognized, or Google's cars, or the Navy's unmanned underwater vehicles. And so all these systems, these autonomy in motion systems, have sensors or databases that tell them what's going on in the environment, like a GPS sensor, a global positioning sensor for an RPA position. They also have on board some kind of smarts, autonomous smarts that embedded in an onboard computer that tells it how to act based on, say, an objective to fly from one waypoint to another. And then they also have some sort of motor or locomotion subsystem that allows it to move around in its environment. And this could be for an RPA, a remotely piloted aircraft, the throttle or the ailerons or the control system. So while the sensors are very important to these systems and the motor parts are very important, the real advances in autonomy are happening in the middle part, the brain part, the onboard smarts. So if you think about removing those onboard smarts to a ground-based system and putting them, say, in a command and control center or a planning center, then you've got autonomy at rest. So many of the advances that we're going to see in this area may come from data feeds or other sensors or satellite imagery, but they're going to be in these ground-based situations, and they'll have a sense part and a think part and an output part. It might be a natural language generator like a Siri interface or a visualization. But once you've done this, you've converted an autonomy in motion system to an autonomy at rest system. So our community right now is beginning to realize that autonomy is not limited to systems that move about or locomote, but they're also very useful in decision-aiding systems, visualization systems, and so forth. And we can multiply the effectiveness of a lot of. If we could go to a modular approach, we could use one module in other areas, and we may also gain some efficiencies in test and validation as well. So
Well,
I hope
thank
that
you.
helps explain.
And thank you very much. And Dr. Bornstein, in your testimony, you mentioned commercial usage for some autonomy technologies. Where do you see the military driving technology development, and where do you see that you will be able to draw from the commercial sector for needed technologies?
Sir, in my testimony, I also mentioned that commercial applications tend to work in structured environments where there's less dynamicism. So despite what you might think about driving on the highways today, there is structure in the highway system. The Google cars, the Uber taxis, those are applications which are dealing with structure. The military, however, is dealing with a dynamic environment, one where we don't know things in advance. We have to have organic sensing and reasoning powers on board the vehicle. So there's a distinct difference there. Where the military can leverage heavily is for those applications that are in more structured environments. Think in terms of logistics, many aspects of convoy operations, forward operating bases. Those are all items where there is structure, where there are commercial entities that are involved with development of systems, and the Army can leverage those capabilities. Or I should say, the services can leverage those capabilities. I apologize.
Well, thank you very much. And Mr. Kelly, the Navy has a unique challenge, and that is air, land, or sea operation. Would you describe some of the technical challenges specific to autonomous systems for each of the domains?
Thank you, sir. And that is true, that we do note that we operate in all domains and simultaneously in many cases. I was reminded today by Dr. Schutte, who is the Director of Research at ONR, that one of the ways to overcome some of the challenges is to start our S&T and make most of our S&T investments in domain agnostic and also platform agnostic. So that's one way that we're going to approach that. If I can, just real quick, I spent a lot of my time as a young guy doing electronic warfare, and I was told it was one of the toughest missions that you'd ever participate in. Complex, dense, can be very confusing, requires quite a bit of training. Not until I got exposed to what it was like in the mine and undersea warfare, of how cluttered that environment is, did I come to appreciate that my electronic warfare environment might be the #2 most complex combat environment. The way that that is also compounded is that the things that we take advantage of when you operate above the surface, ability to communicate in the clear, taking advantage of things like the GPS, are not available to you. So these are going to be really big challenges for the Navy, particularly communication underwater, and our precision navigation solutions that will provide to those solutions.
Well, thank you very much. And Mr. Gates is, again, very precise. My time is up. Mr. Langevin.
There we go. Sorry about that. So to all of our witnesses, what policy and operational concept issues at the tactical and strategic level are most pressing and must be addressed before deployment of more capable autonomous systems? For instance, the unmanned aerial systems concept of operations requires an operator for takeoff and landing, and airspace restrictions in the U.S. Impede testing and training. Integration into the airspace is still an issue, and systems must be able to detect, sense, and avoid. But this is not unique to air, of course. So, Secretary Kelly, do you want to start from the Navy's perspective?
Certainly, sir. Thank you. You've listed off quite an array of challenges. One thing that I would like to mention, when I had a chance to get a hint that the Secretary was going to stand up Deputy Assistant Secretary of the Navy for Unmanned Systems, one of the first places that I went to was an association called AUVSI, the Association of Unmanned Vehicle Systems International. They've tagged on the I on that point. I had a chance to talk to the President and CEO of AUVSI, a gentleman by the name of Brian Wynn, who did not spend any time in the military. And one of the things that we quickly found out in our dialogue was that we have many of the same problems. And so here's an organization not necessarily associated with DOD that is willing to team with us within the defense sector to solve some of these issues that you mentioned, sir, like the airspace issue, the sense and avoid issues. So there's a great opportunity, I think, to team with the commercial sector. I think one of the other areas that, if I can think back in my own time, back in the day as a young guy in flight school, sometimes systems were not as reliable as we see our systems today. And so sometimes you'd be in the cockpit and you would just pray to God that a piece of gear was actually going to function. I think some of the young people today take that for granted. The reliability of our equipment today is unprecedented. They don't question the fact that it's going to work. I think what I'm finding today that's remarkable is that our young people are really concerned about the ethical and moral implications of how these unmanned systems are going to be used. This will also help us in getting the trust that I spoke about in my oral statement of our sailors and Marines. The trust issue is sort of an implied task. We do have DOD directives that talk about certainly weaponizing platforms, but I think the biggest issue is sort of an intangible, and it's this ethical and moral element of what it means to put unmanned systems in combat.
Okay. Other panelists? Anybody else want to comment?
I'll make one off-the-cuff statement. And one of the things that I see in the commercial sector is the issue of responsibility. We talk about an unmanned system, so if there is an accident in the national airspace or an accident on the road, who is liable for the action? As was just mentioned by my colleague, Mr. Kelly, he talked about the ethical responsibility that many people see in the use of unmanned systems. Will the liability for their use will the responsibility of their use who will that fall upon? That's a personal opinion that will be a major issue in the future going forward, both for the commercial sector and for the military sector.
That actually kind of touches on my next question. You kind of beat me to it there, but again, I'll expose it to the other members of the panel. As I mentioned in my testimony, command and control becomes more challenging as systems become more autonomous. So how will you address chain of command as systems become more autonomous, particularly when you're talking about lethality in systems?
Maybe I can start on that. This is a little out of my scope since I'm on the S&T side, but I think, as Mr. Kelly said, I think much of it is to do with trust and proficiency. So one of the things is to try to design in trust into these systems, including engineering the system so it performs well within its scope of operations, knowing when it's exceeding its scope of operations, or the human operator knowing that, making sure they're knowledgeable of mutual understanding of their goals if they're working as a team, or their subtasks, and providing for natural interfaces, transparency and explainability of these systems. It may be better to not have them be optimum, but rather be adequate and be able to explain what they're doing. And finally, training and practicing together, just like any team would win. And finally, I think the notion is that if you can get these systems to co-develop concepts of operations and organizational design, I think that the basic issue, we're not going to just throw things over the transom and expect them to be perfectly integrated into the organization. And I think concepts will be co-developed with the technology.
Mr. Kelly, do you have anything to add? Or?
Yes, sir. Thank you. One of the great things about coming to hearings like this is you learn so much, and I love the phrase of co-develop. I just had a chance to sit down with the PEO for C4I for the Navy, Admiral Chris Becker, and we were talking yesterday about the organizations that provide the infrastructure. So the C2 nodes, the network, the comm pipes, how important it is to get with those organizations quickly, because that can bring a concept of operations down to its knees, even though that you have the finest autonomous system, the autonomous platform that the greatest engineers in the world could have designed. I also think when we start coming up with what are those essential elements of information that a commander, and at the end of the day, it's going to be a commander who's going to be held accountable for how these systems are used. What are those elements of information that they are going to need in order to exercise judgment? We've got to come up with these priority schemes, a way to make sure that that kind of information and data gets to the commander on the scene.
Very good. Thank you, and I yield back, Mr. Chairman.
Thank you, Mr. Langevin. We'll now proceed on a second round. We really appreciate you being here today, each of you. For each of you, beginning with Dr. Zacharias, how are you drawing on or integrating technology efforts being funded by industry through their internal research and development process, or from international S&T efforts being funded through foreign government science funding agencies?
Thanks, sir. Well, let me start with the international efforts first. So we have, we're exploring agreements with international partners, collaborative technical exchanges. The Air Force Research Lab has agreements out with a multilateral agreement there's a technical cooperation effort with the UK, Australia, New Zealand, Canada, and working on a grand challenge in autonomy research. And we're also participating heavily in the V&V issues, because eventually, if we're having coalition operations, we'll have these systems working with one another, and they'll have to be cooperating clearly. So on the commercial side, we're working with the DIUX out in the apologize, I can't remember what it stands for, but the DoD initiative out in the West Coast, Silicon Valley, to try and work with some of the folks that are doing some of the advanced technologies in machine learning, pattern recognition, robotics, and so forth. and we'll be reaching out additionally with more Air Force Research Lab personnel in that direction.
Thank you, and Mr. Kelly.
So I think one of the responsibilities of our office is also to work across the entire enterprise and provide opportunities for industry to participate in demonstrations and exercises. Even though we've been in combat in Afghanistan, I think that the Marine Corps and the Office of Naval Research can be very, very proud of a program that was started a while back. I can't exactly remember when it was, but it was in terms of an unmanned logistics UAV that would deliver, cargo out on the battlefield. And to date, the cargo UAV was able to deliver, could have the potential to deliver over 6,000 pounds of cargo a day. Transitioning that into more formalized programs like ACUS, which is the Autonomous Aerial Cargo Utility System, a KMAX bird. I think that that's an important opportunity for industry to be able to demonstrate their understanding of what the environment's like. I already described our association with AUVSI. We did have a chance in October to speak. It was the first time we could speak as an organization at their AUVSI Defense. And I see many people sitting behind me that were actually there as well, both Army and Air Force. And it was a great opportunity for folks to actually show what was going on, in not only commercially, but in each of the services.
Thank you very much, and Dr. Bornstein.
Like the other services, the Army maintains bilateral arrangements with many countries through the TTCP, the Five Eyes, through countries such as France, Germany, Israel, where we try to develop programs of common interest. In addition, my own organization, the Army Research Lab, has embarked upon a new initiative over the course of the past 2 years that we call Open Campus, which is focused not on giving contracts to companies, but rather developing cooperative research and development agreements where there's a mutual interest on the part of both parties, letting small businesses, who are usually the furnaces of innovation and technology, come to our site to utilize DoD facilities to further what they're doing, together with researchers from the laboratory. We do similar activities with other organizations throughout the Army, and we invite the other services to participate as well. Thank you, sir.
Thank you very much. And for anyone who would like to answer, what defenses exist to protect autonomy technologies from being hacked, resulting in losing control?
I'll take a stab at it, sir. And I think one of the most important things here is a new testing paradigm for autonomous systems that would lean heavy on the cyber side of the house, I think is the most critical piece. Now, one of the challenges, I think, with autonomous systems is that it becomes very challenging to try to test all of the possible scenarios that you could possibly encounter. And so we'll have to work through that. But the VV&A, the verification, validation, and accreditation of these systems, and of course the accreditation will also will have a cyber element to it, means that that we've been able to test and make sure that that it can't be hacked into and taken over.
We just wish you the best addressing, sadly, people who have such ill intent as we see every day in the world. We'll now proceed to Mr. Langevin.
Thank you, Mr. Chairman, and as usual, the Chairman and I are very much on the same page on asking these kinds of questions. I wanted to get to the cyber question, security question as well. Just to build on that, if you could elaborate, what role do trusted foundries and third-party manufacturer agreements play in this level of security?
I'll take a stab at that one too. So my understanding is, what role will trusted foundries and supply chains? Clearly will be. I think we're planning a upcoming study on looking at issues that Mr. Kelly raised, both in terms of embedded systems, reliability, and authority, authenticity, if you will, comms links, vulnerabilities, because in terms of over and above vulnerabilities over and above our normal embedded systems, which we also have those issues of comms links and cyber vulnerabilities, and there are efforts ongoing. I'm not intimately familiar with them, but in terms of establishing trusted foundries now, and certainly many more regulations, say, going out to industry in terms of protecting government IP and making sure that outsiders don't exfiltrate our designs and compromise our embedded systems. In fact, there was a large summer study, by the Science Advisory Board for the Air Force this summer looking specifically at embedded systems vulnerability, and clearly that'll have an impact on autonomous systems.
Thank you.
Sir.
To all of our witnesses, the Defense Science Board identified transition or lack thereof as an obstacle for utilization of autonomous capabilities. What steps are you taking to improve transition of technologies?
Okay, I'll start. In my opening remarks, I mentioned ongoing activity looking at near-term applications of the technology. Those are key and critical to transition and adoption by the force. As I've said many times, it's very difficult to write requirements for a revolutionary technology in which you have no experience. The use of those activities is to try to build that experience base on the operational, the training and doctrine community, so they can begin to build the requirements, the techniques, tactics, and procedures that will ultimately be used and facilitate the transition of technology in that way.
Okay. Mr. Kelly?
Thanks, sir. So also within the DSB 2012 study, they also talked about the autonomous reference framework, which in my discussions with folks at ONR, they're very receptive to that concept. And actually, when I think about it, it makes a lot of sense. It's a three-level, a cognitive level, a mission level, and a complex systems trade space level. So that goes right to the heart that I think that Dr. Bornstein was talking about in terms of the design of these systems. In the Navy, right now, with the stand-up of DASN unmanned systems and the renewed emphasis of DASN RDT&E to energize Naval Research Development Enterprise, and with the stand-up of Op 99, our resource sponsor, we're taking a really rigorous stab at prototyping and experimentation. And this is to better inform the requirements at the front end of our acquisition framework. And so the most important thing here is to get the requirements right. So what we envision is that this will be an iterative cycle, constantly going back to the warfighter in terms of making sure that we got those requirements right.
And if I could follow up, my colleagues covered most of the points. I think this is again. I think the Air Force has learned a lot with its RPA experience, being the lead service and establishing so many thousands of hours of operation in that area, and it has led to a change in operations and how they're used, and issues to do with manning and manpower. And it's also raised other issues, going from how do you pilot these things to actually how you process the information, the thousands of hours of video that you get off of them. And so they raise other areas and opportunities for autonomy. And one last thing I would say, these will be, again, co-developed and embraced more fully with good human systems integration technologies. Again, I think something Mr. Work mentioned a couple of weeks ago, how you get these systems to work closely with humans and make them more understandable and reliable and trustworthy, appropriately trustworthy. You don't want to encourage trust where it isn't deserved.
Mm-hmm. Very good. And I guess to all of you, you've touched on it a little bit already, but how well are you coordinating your autonomous systems investment strategies and lessons learned across the services?
So I think that is the reason. I don't think, I know, that is the reason why our office was stood up, to be quite honest. And one of the things that's different about the DAS and Front Man Shop is I have counterparts within the Assistant Secretary of the Navy for Research, Development, and Acquisition, other DASNs. And if you could sort of picture them as being vertically oriented within a domain, say DAS and Air, a guy by the name of Gary Kessler is DAS and Air, Gloria Valdez, DAS and Ships. They have the whole portfolio of those particular platforms, air and ships. In our shop, we'll be cutting across. We will be cutting across, essentially generating and now supervising, providing oversight, managing a portfolio of just unmanned systems and how that fits into the broader naval operational concepts.
Very good.
I'd be remiss if I didn't try to answer that question, since I'm currently acting as the lead for the Autonomy Community of Interest within OSD. And Larry Schutte is my deputy sitting behind me there. OSD basically recognizes that there needs to be coordination among all the services. It's part of Reliance 21. And ideally, the community of interest should be a forum where subject matter experts can get together and really begin to understand not only what each other are doing, but have the opportunity to cross-fertilize thoughts and concepts concerning the technology. Next Wednesday, the Autonomy COI will hold a workshop at ONR, really bringing together a large number of people to discuss 3 topics: modeling and simulation, test and evaluation, verification, validation, and trust and automation. And those will be 3 topics. Community members will be there talking about it. I can't tell you what will come out of it, but I almost guarantee that there'll be some cross-fertilization, and it will be agnostic, service agnostic in that regard. So there is that definite thrust towards cross-fertilization among all the services, at least at the S&T level.
That's encouraging. Thank you. Well, if nothing else on that, I'll thank our witnesses, and I'll yield back. I have additional questions I'll submit for the record, but thank you, Mr. Chairman.
Thank you, Mr. Langevin, and thank each of you for being here today. And in the future, I'm very, very grateful. Kevin Gates has been a lead on this. He's actually been working in this field for many years, and I'm really grateful for his professionalism, and we look forward to hearing and working with you in the future. And with that in mind, we are adjourned.